From our book Edexcel A2 Physics, we are going to move on to studying the conservation of linear momentum, which is found on page 42. First of all, we are going to take this picture of a pendulum. As you can see here, the pendulum is this structure that is made up of several identical shapes that are hanging on the same exact rod. The thing that can be done with the pendulum is that we can raise a ball on either side of the pendulum and leave it bump into the other balls that are settling under the rod. And then we can watch and study the reaction. And the pendulum is actually a perfect example for explaining the conservation of linear momentum. Linear momentum is an idea that makes us decide on the positions, directions, and movements of several bodies after interacting with each other. The laws of physics will help us understand that. For instance, if, let's say, two cars bump into each other on the road, where will their next positions be? This can be determined through the momentum of both colliding cars. So, the laws of physics will help us analyze what happens when two bodies collide. For example, we can take these two balls that are shown before collision and then are represented after collision, where we can see how each ball diverged into its own separate direction after colliding. So in collisions, we have at least two objects, each object going into its own direction and leading towards each other, which will eventually make them bump into each other. Of course, collision causes momentum to change. So the laws of physics are going to help us determine what happened to the momentum of each body and where will their next positions be when they collide. The laws of physics allow us to calculate where will they go after the collision. The principle of conservation of linear momentum can be used to predict the motion of objects after collision, which is exactly what we were talking about. So let's start with the explanation. First of all, we have P1, which is the momentum of object number 1 before collision, and P2, which is the momentum of the second object, and of course we're talking before collision. And since P1 and P2 have opposite directions, then one of them is positive and the other one is relatively negative. After collision, we care about the sum of P1 and P2, which is the addition of the momentum of both objects. Of course, the sum of P1 and P2 before collision is completely different than the sum of their momentum after collision. Since of course, collision will change their direction and velocity, which means that their momentum will eventually change, since we know momentum depends on speed and weight. Of course, the weight will never change, but the speed will actually change according to direction and magnitude. So here we have the equation, which is the sum of P1 and P2, which says the sum of P1 and P2 before collision is equal to the sum of P after collision. Let's go back to the pendulum to take an example. We can observe the raised ball and the ball right beneath it. Each one of them has its own momentum before collision. And once we release the upper ball, their positions will change due to collision. Hence, the original positions P1 and P2 will eventually change and lead to new positions after collision. And here we can go back to the original formula, P1 plus P2 is equals to P, keeping in mind that their positions will change after collision. So now we can calculate the p after collision, which will actually help us in many other equations, such as calculating velocity, for example. For now, we have introduced the principal conservation of linear momentum, and thank you.